Hello, everybody. Welcome back. And right now we have Evan Shapiro and Brandon Kase from Coda going to teach you how to run a validator on Coda. So, Evan, you are going first. Take it away.
Awesome. Hey, everyone. I'm Evan. I'm one of the co-founders and the CEO of O1 Labs. We are the team that is building Coda Protocol. So let me figure out how to share my screen here, and then we will begin. Okay. Does this work for people? Okay. Cool. So agenda. So here's the plan. I'm going to tell you a little bit about what is Coda. Then I'm going to tell you a little bit about how does Coda actually work. Then I'm going to tell you about the Genesis program, which is an exciting way for people to get involved in testnet and eventually mainnet and have a stake of tokens to participate in consensus with on mainnet. And then Brandon will be giving a demo of our testnet. Yes, let's do it. So what is Coda? Coda is a cryptocurrency. It's a new cryptocurrency that swaps out the traditional blockchain for a zero-knowledge proof to achieve an incredibly lightweight blockchain. So we might ask ourselves, well, why do we care about having a lightweight blockchain? Well, the answer is you get way better decentralization and usability. And let's jump into those now. So decentralization. We define decentralization as the participation and permissionlessness provided by the cryptocurrency. Really what this means is we want everyone to have equal access to cryptocurrency, permissionless being you don't have to ask anyone's permission before you can use a cryptocurrency, and participation being that everyone can get access to the cryptocurrency and be involved equally in how it works. And this is something that's possible with traditional blockchains, but only when the blockchain is kind of just starting off, when it's small. What happens is the blockchains get very large over time. And when this happens, once the chain gets very, very large, you have to start depending on the few nodes that have access to the whole chain for access. So at this point, we have kind of a conundrum, right? Because we have this huge chain, which is great because it has a bunch of transactions in it, but also maybe we can't run nodes anymore. Maybe it takes terabytes to run a node. You have to be an organization with the resources to do that. And you can imagine in the limit this being kind of bad, this being the case where there's maybe only a few organizations that end up running nodes. And we end up depending on those organizations for accessing cryptocurrency. And that's kind of the opposite of what we want in the space. We want anyone to be able to use this stuff. We want it to be for everyone. And we can see this is kind of a real problem because if you look at Bitcoin and Ethereum's full node count, it's not exactly the up and to the right that you kind of want from a chart like this. For Bitcoin, for the last 2-ish years, it's been kind of the same amount of nodes running Bitcoin. And this is probably because it's all the same services that run the ecosystem right now, but it's not really people using it permissionlessly that are new, which is, we think, bad for this technology. Actually, its advantage is getting out into the world. Things are a little even worse for Ethereum, where you can see that the node count kind of went down a lot from in 2017, you had 30K, 40K nodes down to today where it's now less than Bitcoin and seems to be going down more. It's actually super hard to run an Ethereum node if anyone's tried. It takes a long time to get set up. I would imagine that's probably connected to how this is. As these chain states get so huge, it becomes really hard to run them. That's why we want to have in Coda a very lightweight blockchain. So how do we do this is usually when you have a blockchain, you have to download the whole history to get this permissionless access. In Coda, what we do is instead you download a zero-knowledge proof. And the zero-knowledge proof represents the same computation as checking the history, but the zero-knowledge proof is extremely small, about the size of a few tweets, and very quick to check, just a few milliseconds. The result of these is that we get very low constant resource use over time, which means full permissionless verification for everyone. Everyone can just download these zero-knowledge proofs on any device, not just their desktop, but their phone and their browser, wherever, and they can get permissionless access to the chain. Awesome. The other half of what we do is we support an uncapped number of participants via our consensus mechanism, Ouroboros, which means that we can have any number of people participating. We're not capped at, a few dozen or a few hundred. We can go as big as the gossip network allows, which could be thousands or tens of thousands or even more, depending on the networking layer, which is amazing because we can have so many people participating in the protocol. Okay, so we talked about decentralization. Now let's talk a little bit about usability. So I'm going to define this as just kind of, making it easy for people to securely use cryptocurrency. And the problem is today it's impossible to permissionlessly bridge this 100 gigabyte blockchain to end user devices. You have kind of this need if you want to access cryptocurrency permissionlessly to download this whole history. Can't really do that on your phone or your browser, not really. So this leads to a sliding scale between how much permissionless you get and usability. Where on one hand, you got something really easy to use. It just uses your Google login or whatever to get in, and on the other hand, you have like your desktop client, which takes a long time to get started with. You got this sliding scale, and it's not great. With Coda, with our zero-knowledge proofs, you get this full node instant verification everywhere. For consensus nodes, you can spin up a node in minutes instead of days or weeks. And for browsers and phones, you get our permissionless SDK, which we'll be building with instant things like you can imagine building like instant tokenized currencies, assets, app tokens directly on end users' devices. You can just get all of these on those devices. And we also kind of think about if we imagine the future with zero-knowledge proofs. Well, right now, there's kind of like this misbalance. Oh, and also, I should just say, yes, we'll answer questions at the end. Cardano did originate Ouroboros. We can talk about that more later. Future with zero-knowledge proofs, though, like you imagine right now, there's kind of this asymmetry between us as like users and the computers we interact with. You have like these giant corporations like Facebook making like huge decisions on our behalf. And right now, there's kind of this huge asymmetry between what we as people use on the internet and what the internet is trying to get out of us. Zero-knowledge proofs can potentially be a tool to counteract this via both like the ability to have verified computation. We can actually have other devices, other computers, prove to us they've run computations in ways that are actually correct and benevolent on our behalf. And we can also have privacy, so we can limit the degree to which we are leaking information and the degree to which computers are able to take advantage of the information we're providing to them. So we see Coda as also being able to help in this domain as well through zero-knowledge proofs, which is exciting. Okay, so we talked about why we might care to have a lightweight blockchain, why these zero-knowledge proofs are important, but we didn't really answer, how does any of this work? We didn't answer what even is a zero-knowledge proof? How did these let us instantly verify the chain? So I'm going to attempt now to explain zero-knowledge proofs super quickly. Hopefully you understand them after this. So let's just look at a regular program first. So we got a regular program. It's got some inputs. It's got an output. We're going to call this program my program F. And we could also imagine F as a function that takes in a bunch of arguments and returns an output, right? So this kind of makes sense. We could imagine coding this in Python or whatever our favorite language is and getting out some output. What a snark does is it introduces two new programs, which I have here. One we'll call the prover, and one we'll call the verifier. So both the prover and the verifier take as input our program F. So you could imagine this as being similar to kind of like taking the source code of F into the program. What prover does is it takes an F, an inputs, and a supposed output for F and those inputs. And it has the property that it can return a proof if and only if you pass those inputs into F, you get the output that you're claiming you would get. And then you can get a proof out. If the output does not match F in the inputs, it doesn't return a proof, can't do it. What verifier does is verifier takes an F, the inputs, the outputs, and that snark proof, and it returns true if that snark proof was created correctly. So you can imagine the verifier is checking whether F actually, if you ran it on that inputs, would produce that output. Now what's cool is that F could take a really long time to run. F could take 1,000 years to run on some crazy supercomputer, but once the prover is done producing the proof, the verifier can check instantly whether the output of F is what it is supposed to be. So you can check on your phone or wherever instantly. And you can imagine how this factors into Coda with actually this being the specific way that Coda works. So here's Coda's like F function. You give Coda, you give F the most recent block, and you give it a proof that the previous block had a valid history and is correct and whatnot. And F is going to return either true or false. It's going to return true if the proof, the last proof for block I-1 verifies, and if block I is a valid successor to proof I-1's block. Otherwise, it's going to return false. So you can imagine F being like the verification function in Bitcoin or any other cryptocurrency. F is just Coda's verification function. What we can do now is we can pass F into the prover itself. So we pass in F, the block, the proof, and at the output we want it to be true, right? We want the block I to verify. And now we have the case that we can produce a snark proof if and only if block I is a successful successor to proof I-1, which itself is true. Great. And now once we've done that, as a verifier, you can really quickly check whether or not if you did run the verifier on the most recent block, it would return that the blockchain verified or not. So you can do this all very cheaply, and you can kind of get a sense of where the recursion comes into play, because the function F is actually recursively checking a previous proof, and we use F to produce the next proof of the current state. So maybe that's like a little bit of like, funny little feedback loop of recursion there, but that's how we get the property in Coda. We can quickly produce these proofs and everyone can then verify them. So the result of this, again, is instant verification. It means everyone is a full class user, no need to depend on access to a full node because everyone just like is a full node. It means it's easy to participate in consensus because you can get started really quickly just by downloading the zero knowledge proof and the current set of the accounts. And you get instant permissionless verification for end users on like, normal end user devices. Cool. The other half of this, which I mentioned briefly earlier, is Ouroboros. And I'm going to very quickly describe to you how Ouroboros works in Coda. So here's the idea at a very high level for most proof of stake algorithms, but particularly for Ouroboros. We divide time into like these slots, and each slot we want to give it one block. We want to select who gets to make that block randomly by stake. So you can imagine we can build a little pie over here, and we can give a little slice of the pie to each account based on what % of the protocol they own, and we can imagine the protocol is going to kind of randomly throw a dart somewhere in the circle, and that account is going to get the permission to produce a block for that slot. So you can imagine that every time there's a slot, your likelihood of being chosen kind of operates this way. So now let me tell you a little bit about why this actually works as a protocol and give you some more intuition for how it's working under the scenes. This is probably the quickest ever explanation of this algorithm, but like, let's give it a go. So we talked about these slots, and I'm going to introduce a rule that you're just going to have to trust me on. If you can read the paper, see other presentations if you want to understand why it's the case. But basically, we're going to have this rule, which is that an adversary has basically zero probability of creating a fork that is more than 8K slots long. You can imagine that the more slots we have, the harder it is for an adversary to win a lot of those blocks. We're going to say that 8K slots, just not going to happen. The likelihood of an adversary with close to 50% of the stake winning 8K slot long fork and being able to create that is extremely, extremely, extremely low. So now we have this property, and now you can imagine that we get like some level of like, separation between the front of the chain, which maybe can change, and the very back, which is very stable. The question now here is we have this property. How do we update the ledger to take account of people that update their stake, change their delegation, etc.? The problem is that let's say that we were to do this at the very, very tip of the chain. We were to change like whoever gets the next block gets to set the next ledger and the next randomness for that who gets to win. You could imagine that they might be able to create a fork at that point and be able to choose exactly what ledger and what randomness is used at the tip. And maybe they could even choose that such that they could have a higher likelihood of winning future slots and blocks at that point. So we don't want it to be the case that you can just like at any point change the ledger to being like whatever you want it to be, because someone could change that to be something that's more in their favor, then they could take over the chain. Very bad. But we can use this 8K rule to fix that. So what we do in Ouroboros is we divide time into epochs, where an epoch is 3 sets of these 8K slots. Now, let's say that on mainnet, we're able to succeed properly with the parameters we're aiming for. We're able to receive, like, K is going to be around 1,000 slots, and we have around 30-second block times. This turns into an epoch being around 8 days. So what happens during those 8 days? Well, there is some randomness in the ledger chosen during the beginning of this time, which we know already is safe. We're just going to inductively assume that it's safely chosen. And then we're going to say that 1/3 way through the epoch, we're going to set what the ledger is going to be for the next epoch. This is the ledger that stakes will be drawn from for the next epoch. And then 2/3 through this, we're going to set the randomness for the next epoch. And then we're going to start the next epoch at the last one. Why does this work? This works because we have a whole 8K slots here in the middle for setting the randomness, where no one could have completely controlled what that randomness was going to be. No one can create a fork that long. No one's going to be able to control exactly the randomness for those 8K slots. And similarly, we set the ledger before we started setting the randomness. So no one knows what the ledger is going to be until the ledger is set safely, and then no one knows what the randomness is going to be until the randomness is set safely. No individual or adversary is able to determine exactly what is going to be chosen for the next epoch. However, the network itself is going to choose so in a way that moves the next ledger along and updates the randomness safely. So that's why in Ouroboros, things are set up into epochs, and that's how the stake distribution updates at every epoch. If more, you can check out more presentations on this, but that's the basic idea. So what are the benefits of this? Well, because each block has exactly one creator, it's not like BFT where we have a bunch of people getting involved. You can have unlimited participants in consensus. You're only limited by the gossip net layer. So someone can come along, produce a block, it gets spread around the gossip net in just a few seconds. Everyone can see it, great, move on to the next slot. Someone else wins, they spend around the whole network. It's very efficient to do that. The other benefits of this are that there's no slashing, there's no bonds, there's no minimum stake, and you can keep your private key in cold storage. So these are all really awesome if you're thinking about running a node on Coda, because it's just way more lightweight to get started doing so. You don't have to worry about all these other kind of things behind the scene that could, threaten your stake that you have already. It just has these properties. There is a drawback to this, which is that you do not get instant finality with Ouroboros. I want to mention that because you never get anything completely for free. You do get confirmation still really quickly, but if you're doing a big transaction, you might want to wait like a few slots, which will be like a few minutes, sort of similar to proof of work in that regard. But as a node operator, it's like really, really, really awesome, and it's really great for participation because of that. Okay, so a little bit about the economics. There's going to be 1 billion tokens at launch. And there's going to be around 12% inflation at launch, going to around 7% after the first few years. This will be going to block producers, so if you do have a stake on Coda, this is like the inflation to expect. There's another part of the system as well called the snarketplace, which is that I mentioned before you have these snarks which represent these zero knowledge proofs. I'm using zero knowledge proofs and snarks like interchangeably. That's cool for people. So you have these snarks that represent the blockchain being valid. We also have to take all the transactions and make snarks corresponding to them so we can kind of fold them into like the master verification snark. So there's something going on in Coda where you can join as a snark worker to make snarks for these transactions. We don't want users making the transactions themselves, making the snarks for the transactions themselves. That's sucks to run your computer to do that. We want these snark workers to be making the snarks. And then the way the system works is block producers buy snarks from the snark workers. They accept transactions and they earn the spread between the snarks they bought and the transactions they've accepted, the transaction fees they've accepted. Because they have to accept snark work for every transaction they bring in. There's like an equivalency there. They can get the spread between it. So if you're a snark worker, you can contribute compute on Coda to make these snarks, sell them to the block producers who want to include them so they can get more transactions into the system. So basically everyone wants there to be more activity, and there's opportunities to contribute both compute and to contribute staking. All right, so let me tell you a little bit about the Genesis program now. So Genesis program is just like a program we're launching during testnet to bring on 1,000 people for basically being the first block producers on Coda on mainnet. So each person will receive, who gets into the program, 66,000 tokens. This will correspond to, you can think about the billion token number earlier too, but 6.6% of the protocol distributed this way at launch. One thing that's kind of cool about this is when I was doing the math for this the other day, it's equivalent to, I believe, 187 2080 Ti GPUs for an equivalent stake on Ethereum of hash power. So if you imagine oh, I want to earn an equivalent percent of Ethereum's hash power, you'd have to buy 187 2080 Ti GPUs. Hopefully that gives a sense of this is a fairly substantial grant to get involved in our testnet. So if you want to do that, please go to our website, apply, join our Discord, and then wait for instructions on how to join on February 14th. And then you can get started participating in the testnet and applying for the Genesis program. So now I'm going to kick things over to Brandon, who will tell more about how to join the testnet and stuff. Now we have to figure out how to transition. So I think I'm going to leave. I'm going to stop sharing, and then Brandon can share after that.
Hello, everyone. Just give me a moment. Okay. Hopefully you can see my screen. I can't see the chat to verify it, but someone will tell me if you can't. Yes, so I'm going to do a quick live demo of joining our testnet. So I'm going to use Google Cloud for this, but you can do so on your own laptop, on a computer that you have in your house, or in the cloud on AWS or Google or Azure. So if you go to console.cloud.google.com, you can create an account. You can sign up for a $300 free trial. I already have an account, so I'm not going to do that now. In Google's Cloud's platform, you go to Compute Engine, VM instances, and you get to this screen. You press Create Instance here. And then we give it a name. Let's call it Trustless for the Trustless conference. You pick a region that is close to you. I am currently in Seoul, South Korea, so I'm going to choose Seoul. And then the machine type on Google Cloud, the N1 standard 4 is good. It's like four CPUs, 16 gigs of RAM. You should be okay with 8 gigs of RAM as long as you're not being both the snark worker producing the snarks for transactions, as Evan was saying, and also a block producer. So as long as you just do one of those things, you only need 8 gigs of RAM. For your operating system, you press the button there. We support Ubuntu 18.04. And let's make 25 gigs of RAM just so we can support lots of accounts, among other things. And then now we have to open our network to allow folks to connect to us, because this is a peer-to-peer network after all. You press that button there and then go to networking. And here we just put a tag that we can use to talk about this VM instance in another section. If you go to security here, you can put your SSH keys here. But if you don't know what that means, don't worry. There's a way to connect to the machine without needing to put your SSH keys here. So then you press create. That'll take a minute or so, but at the same time, or while that's going, we need to actually open our ports. So if you press the menu again and then go to firewall rules under VPC networks, we can create a new firewall rule called Coda Trustless Firewall. And then the important things here, we want to set the direction of traffic to ingress, because ingress is allowing folks to connect to us. We want to target this Coda Trustless tag that we just created. We want to allow all IP addresses, which is 000/0. And then because there's people all around the world in our testnet. And then we want to open the ports 8302 and 8303 on both TCP and UDP. And these are the default ports we use to interact with other nodes on the network. And then create. By now, our VM instance should be ready. So if we go to Compute Engine, VM instances, we find the instance we created, Coda Trustless, and press the SSH button. Then this will start a window that you can use to connect to the node that we just turned on. While that's loading, you can go to codaprotocol.com/docs/getting started, and you get to this screen. You can see my SSH started. There's a command here for installing Coda on Ubuntu. These first two just remove existing installs, so we don't need that. So we can take these 3 lines, paste them here, and then wait a little bit for everything to download. And when that's ready, we go to My First Transaction and paste this, and we have a validator connected to the network. And I am going to show that, but we need to wait a little bit for the install to happen. So I want to maybe open up for the first question while we're waiting for that. Hopefully Evan found his way back into the chat.
Yes. Let's see.
Evan, would you like to take a question?
Is Coda able to interoperate with other blockchains, Ethereum, Cosmos, Tezos? Will you ever use Chainlink? Okay, I can take a shot at this one. I think so. The answer is that we want it to be able to do this. It's not able to do this right now during testnet. I think there's some really cool possibilities down the line, though, using zero-knowledge proofs, because you can have instant zero-knowledge proofs of things on other chains between the chains. So it's like a way to, you can imagine like if chains had to like recursively like look at the entire history of each other, you probably would be in a bad place. But if look at zero knowledge proofs of each other, then they can like verify each other. So I think it's early for this, but be cool things down the line. Next. Okay, Brandon, this is one for you. With 8 GB, you still need 4 CPUs? Question mark.
You need, so with 8 GB, you need 4 CPUs if you want to be a block producer, a validator that's actually, throwing the dart at the pie chart, like running Ouroboros, as Evan explained. And that's just because given the constants that we've chosen right now, you won't be able to produce the recursive snark proof fast enough without the 4 CPUs. If you're running your node as just a validator that is not producing blocks, but you just want to join, verify that the blockchain is valid, send transactions, you do not need 4 CPUs. And if you're joining as a snark worker, compressing transactions, I think we have tuned that so that 1 core on a machine like this should be able to produce snark work fast enough. But the more cores you have, the more work you'll be able to do. How's that?
Cool.
And I think, Evan, this is actually almost ready.
Okay. There's a bunch of questions now.
Just take one more question.
Okay. Also, we got some feedback on, definitely, I think for zero knowledge proofs, understanding them. I hope one day they're as easy to like kind of abstract away and explain as hash functions and public keys, but it's not there yet. So there's definitely more material out there. Check out like our website and Discord if you're curious about more. Hopefully we'll have more stuff in the future to explain more stuff about it. Okay, next. Why is slashing not necessary? On the Coda testnet, they had issues with stake pools creating multiple blocks in the same height. Isn't slashing needs to disincentivize this? So that is one potential solution to disincentivizing the multiple block production question. The problem is that here's my perspective on it anyway, is it's way better to solve these things if you can at like the gossipnet layer or at like the layer of like what's considered acceptable and not acceptable in the protocol, rather than like making it about economic incentives. The moment you make it about economic incentives, you have a lot of parameters to tune, makes it really hard. The nice thing about if you imagine gossipings around in Ouroboros is you can imagine that basically there are certain behaviors that nodes are supposed to do. Like for example, not sending you like certain patterns of blocks. They're like not supposed to do that, and certain things they are supposed to do. And what you can do is you can ban nodes based upon the behavior they're presenting. That's enough to avoid the gossip net flooding and not enough to break consensus. So that is the thought around slashing right now for that particular problem in any case. Brandon, we're ready, right?
Yep. So
okay,
let me just,
so we can get to those.
This will take 5 seconds. So now we went to the my first transaction section of the docs. We take this first code block here. We always will keep this up to date with instructions on how to connect to the existing network, and then we just run it. And now we're done. I'll leave it up so you can see the cool logs. But the one thing that I want to mention is you can do this now. I mean, we just did it. You will connect to the network. Right now in our current testnet, the amazing community has found an interesting bug that where if we have more than or on the order of say 100 or so nodes, part of forks don't get resolved properly. So we believe this is a networking problem. So we want to investigate this, and before we supervise behaviors and to more people to find issues on the testnet for the Genesis program. But yeah, feel free to join and test it out. You can connect. You just might not connect to the real tip of the blockchain. So yes, we'll just leave this on in the background, but maybe we can take another question.
Sure. Let me find one. Okay. Next question. Testnet program has started, right? If so, is there a dashboard or explorer for people to see stats? Yes, there is. The next question is a dashboard posted for people to see stats. So check out that link. Some cool stuff on.
I can also pull that up.
Yep.
codaprotocol.com/testnet, and my internet is not super fast, but here's some stuff. And there's more that you can explore here. The full dashboard. And I want to say also the demo that I ran through. We have this version, a version of this as a YouTube video called "Set up your Coda node in 5 minutes" that Connor Swan, our reliability engineer, made. So you can check that out to follow along.
Cool. Brandon, do we have more, or should we just like keep answering questions now?
Yeah, let's just keep answering questions. I don't know if do we want to switch back to your final slide?
Yeah, it has links on it and stuff. I think we should.
Okay. I'm going to stop sharing, and okay, I'll stop sharing.
Okay.
That didn't work. How about this?
Okay, one sec. Oh, I'm just pulling up presentation. Okay. Just some links at the end there. I think a lot of these got posted in the chat, but maybe some of them are higher up now. Check out our Discord, progress on our Twitter, our website, Genesis program. I'll just leave this up as we answer any more questions. Okay, let's see. All right. Mobile phone. Yes. So there's different ways that you can imagine every Coda node is like a full node, but like I think there's like 3 kinds of ways you can imagine running a Coda node. There's like running it just to like participate in the network in a permissionless way. There's running it as a block producer, and there's running it as a snark worker. Particularly for snark workers, I think the answer like will be yes once like the code is compiled to like phones and everything. The question then becomes like, is this something you actually want to do or not? And then like, I don't know. I guess phones are like fairly power efficient, so it's like not going to be like the worst thing in the world to produce the snarks on your phone. So like, sure. I mean, we have to get it compiled for phones first though, which has not happened yet. But someday, I think yes. Although it may not be the most efficient way to produce snark work. Yeah. Benchmark so far in TPS. No, this is not something we've like focused on heavily so far. We've been able to like test a lot of like the node operator stuff, as well as like the SDK stuff we wanted to start doing without really focusing on TPS. I don't think we've really started optimizing that part of the code at all. So it's probably, I think, still like around 1 or less than 1 TPS on Coda. That said, once we start optimizing it, it should get really fast, really quick. We also don't have to worry about the problem of like, oh, like all these blocks are so heavy. It's like going to be really, really hard to like start syncing things to it. We can imagine having really big blocks on Coda, and it's really easy to sync to. In fact, like as long as like the gossip net can support whatever bandwidth of transactions we're trying to send out, should be able to do it. So at some point, we should see like really crazy TPS when we start optimizing for that. Okay. How do you plan to build out your ecosystem so the incentives are aligned and it's worth people's time in terms of participation and future growth potential? I keep asking myself, why do we need another blockchain? I think it's a great question. Why do we need another blockchain? Like, yeah, I think the answer is just that like the technology is still moving super fast in the space. There's things like zero knowledge proofs that didn't exist when Bitcoin came out, at least in the way they do today. And I think that like that is like why we need new protocols, because like I think that if we think about the existing protocols right now, we can't have arbitrary numbers of participants, and you can't access it permissionlessly everywhere. And those are like the 2 things cryptocurrency needs to do. That's why we think code is important. That's why like we're working on building it out. Yes, and I think like a good question here also is about like the ecosystem and how do we actually like work on building that? I think that the key right now is just making sure that the way the community is progressing is something that's like inclusive, and like we're just building out like a big team of people that like all can work towards like this like shared mission. I think that there are different like kind of stages to this in time, where like initially we just like care the most about like people core to the community and node operators and developers, and eventually it becomes more broad as more people start using cryptocurrency. I think there's a lot I could say here, though. I'll just move on for now so I get to more questions. How do you see Coda challenging the status quo of other blockchains that are proof of stake? I think, yeah, like I think the Genesis program is like really takes advantage of the number of participants we can have in Coda, so we can have a lot of people in Coda at the same time. I think also like it's a great opportunity to like get a big stake of tokens on a cryptocurrency and be able to stake through Genesis. I also think that there's just like a lot of really cool properties of Coda that should make it an interesting chain to look at for doing, node operation on. How many people in your dev community / are they distributed? So mostly we've been focusing on node operators right now, and other people that are kind of core to the beginning of the protocol. Yeah, they're definitely distributed right now. I think like all over the world. I think for Genesis we had like I think more than 50 different countries like signing up for the Genesis program. I think way more than that. I think it was like 70 or something. But right now I would say there's probably around a few hundred people that are like kind of like actively engaged in our testnets that like have signed up to like stake in the latest one and such. And on our Discord, I think we have like a few thousand members. I think check out our Discord. It's active. It's like cool things going on, which is fortunately the link also right below. But yes, let's see. Next. Also, Brandon, feel free to chime in on these too. I'll just keep going though. Where can we get these slides and who can I engage with? I don't know. That's a good question. I just made these slides. I don't know where you can get them. They're on my computer. I think maybe talk to Claire, who is also in the chat and from our team, or go to the Discord. Probably just like message Claire on Discord is the best thing to do there.
Evan, we can post these slides to the Trustless 2020 channel in our Discord.
Oh, cool. Yes, we can. Let's do that. At some point,
and we'll send them to Shinju.
Yes, let's do that. Okay, so check out that channel.
and yeah, feel free when you join our Discord, we can continue the conversation in the Trustless 2020 channel because we might not get to all the questions.
Yes, cool. Is there a light client? The answer is that, well, what is a light client? A light client is a version of the software that doesn't have to download all the data. That is true for Coda. All versions of Coda don't have to download all the data. But then the very question of a light client is like, usually when you have a light client for a protocol, there is a security trade-off because you still have to trust someone to get a lot of the data from, to like kind of bootstrap to. And Coda, the zero knowledge proof, handles that for you, which is great. So is there a light client? Like, I could also, I guess, interpret this to be like, is there a version yet that works on like phones and browsers? The answer to that is not yet. But like the current version that you use with Coda, you don't have to download all the data. It's really quick to sync to. So yes and no, depends how you define light client. The dashboard, yeah, sorry, go ahead, Brandon.
Sorry, and I just want to add, we are working towards making the versions, the non-consensus versions to work on things like a web browser.
Yes.
In progress.
Yes. The dashboard does not really provide quick stats. Like, this is less of a question, more of just like a statement. I think it's like kind of true. I don't know, Brandon, where are we on like?
Yeah,
like
I responded to that one in the chat.
Oh, cool.
So we can skip that one.
Okay, yeah, it's on the chat if people want to see it. Well, hardware requirements are going to change in the near future. I think like no. I don't know, Brandon. Do you have thoughts?
They will not change in the near future. They may change in the future. We at this moment we are not going to commit to not changing them before mainnet, but that's something that soon we will commit to what the requirements will be for mainnet.
Yes, we would like to say no, cannot commit, but like it's going to be around there. You're not going to have to like, our goal here is a lot of participation. We're not going to start requiring like, some crazy 64 core CPU probably or anything like that. Okay. Yes. Okay. Yeah. Also, yeah, someone posted Gareth Davies Block Explorer in the chat. This is also like a community member made, but it's like a really awesome Block Explorer / like dashboard. Yes. Let's see. Ecosystem question. Cool. Okay. Yeah, no questions on that. That's a trick question. Aha, yes. I thought so. After the testnet minute launch, where do you see the utility coming from? What kinds of use cases? I think that the key here kind of comes back to like, okay, we have a network that's like super high participation. What do we like, you know, what are we all going to use it for? I think the answer is kind of falls into like this like permissionless usability kind of domain. Like, I think it should be the case that we should be able to like all put like, you know, tokens everywhere. They should all be accessible in our browser. We shouldn't have to rely on any third party for like, oh, like asking permission. So like, you know, the Coinbases of the world, can I use this software or not? Can I use it in my country or not? I think that it's like a really powerful property of cryptocurrency, and when the Coda is like exceptionally good at, because it's just like this ability to like, you know, really quickly, instantly sync to the current chain. I think like I imagine Steam, like I imagine this being both kind of like app tokens as well as tokens that represent like, you know, currencies and like other kind of like assets and things like that. So pretty abstract, but like I think there's a lot of really cool possibilities once you have like permissionless access to like a cryptocurrency, which like I think is really exciting. Another thing I can kind of add for here. Oh, sorry, go ahead, Brandon. Yeah.
I just want to add the big thing is because we only have to check the snark proof to sync to the chain. You can literally like visit a website, and when the page loads, you know, within a second or within a few seconds, be fully connected in a decentralized manner, trusting no one. And that just unlocks the ability for all sorts of new applications that, you know, can't really exist with other chains without delegating trust anyway.
Yes. Cool. Do you guys have a strong UX UI focus? Most blockchain projects focus on functional things of the blockchain. We do have a very strong UX UI focus. Brandon leads that team. Brandon, do you want to talk about any product engineering things?
Yes. Or at least I lead the engineering side of that. Yeah, we have a design team. We have a product engineering team, and yes, we care about UX and UI. We think it's really important for these projects, and we're surprised that more projects aren't also focusing on it as much. Yes.
Yeah, and we also have a wallet we're working on that like should make it really easy to get started with like, you know, Coda, even besides like the CLI approach we have right now. At some point, you'll just be able to like, you know, double click something that'll live in your taskbar.
Yes, and the intention for that also is to enable more validators who maybe aren't comfortable with the command line to participate in the network. And yes, we're working very hard on that.
Cool. Just a thought. Can you compile Haskell-based Coda to WASM such that it can work on all browsers? This is how our approach is. So it's OCaml, but we're basically the same idea. We are, as part of like trying to, you know, have like, you know, this node that works in the browser and on phones and everywhere. Basically, yes, compile OCaml down to JavaScript. It's a little more involved than just let's just compile it down to JavaScript, but that's the idea. If curious, there's like networking.
that is one step.
Yes.
Yeah, it's called JS of OCaml. I'll post the link here. Unfortunately, well, the WebAssembly backend for OCaml is still in flux, but there is a JavaScript backend that's very, very efficient. And we have demos of portions of our native OCaml code compiled to JavaScript working in the browser right now. We just don't have a full node working yet.
Cool. OCaml's awesome. Agreed. Does anyone else have any questions? For me, for Brandon, comments on cryptocurrency? I don't know.
Yes. Let me take this new one. So it's there's a vestigial log statement. Like the organs that people don't use anymore. We at one point had our peer-to-peer discovery layer was the Kademlia module taken from the Cardano project. Well, we sort of wrapped their existing implementation and connected it to our OCaml code. But since then, we have moved away from that, and we're now wrapping libp2p and connecting to that. But in our current version of our client, we still have the log statement that says Haskell Kademlia port. Yes. HSM support. This is an interesting question. So let me first say that you don't need HSMs because you don't need to expose your private key with expose a private key with a lot of funds in it, with really any more than like 1 nano Coda, which is the Satoshi of Coda, to stake. Unfortunately, HSM support is very difficult because the process of producing a block requires creating a snark, and creating a snark uses the private key. So essentially, we'd have to make the HSM be able to produce snark proofs, which is quite hard. We are working on support for a hardware wallet for signing transactions and stuff like that, and that should be coming soon. But as far as actually during validation, we will not have HSM support in the near future. But because there's no slashing, it's not as necessary. Cool.
Any
tips for being in the? Go ahead.
Any tips for being in the top 1,000 validators? Yes. We want to bring in people that are going to be able to run nodes successfully on mainnet. That's like the whole point of the program. So we consider testnet to be like, the practice ground for everyone to do that and like to work on the software together. So yeah, but besides applying for the program, like reading the terms and conditions, understanding what's going on, joining the testnet, being on the Discord, participating in the, getting points on the leaderboard and things like that. Just like participation, getting familiar with the software would be my tip, which is just like,
Yeah, and if I can add, also even if you're not technical, or if you know someone who's not technical, there's plenty of non-technical ways to contribute to the testnet as well. And there's technical ways to contribute to the testnet that isn't just running a node and operating a node on the testnet. So helping with tooling, contributing to tooling, as well as to the protocol itself, are ways to show that you are committing to Coda, and so Coda will commit to you with a grant, potentially.
If I can give a shout out particular, like we're trying to translate a lot of the docs right now to like a lot of different languages so that anyone in the world can participate and like actually get started with. So that's a particular effort. If you know any non-English languages, please check out that channel in the Discord.
And then go ahead.
Oh, I think you're the best one to answer the next one, but yeah, we're wrapping with P2P now, basically. Yeah.
Yes, and we're wrapping the Go implementation of libp2p because that has, at least at the time we started wrapping it, much more support than the Rust version. But yes, in the current build, we're wrapping parts of libp2p, but we're still using the gossipnet, like a custom gossipnet implementation, and soon we will be delegating to libp2p for the gossipnet as well.
Yes. Yes, so many questions. Thank you, AJ. Is there any more questions? Yeah. Yes, I think we agree. 1,000%.
That's a very contentious statement. But we believe in strong static typing for everything we can in the protocol. So that is sort of the rationale between behind like something like Rust, being something that we would prefer to use, and it's why we're using OCaml. But yes, Go is still wonderful, and you can produce great things with it. But for our protocol,
I guess if ever. Oh, sorry, Brandon. I think you cut off. I interrupted you. Go ahead. Brandon? Brandon, are you there? Hello?
Yes.
I think your connection just got really screwed up for like a good few sentences. Oh, Brandon's symbol turned into a Wi-Fi thing with an exclamation point on it. That's probably bad. But let's see. Yes. I imagine that if at some point in the future the Rust thing became like better than the Go thing for what we're doing, we'd probably just switch to it because we think, at least internally, we like Rust better. But like maybe Brandon can chime in and say no, at least in the chat. But anyway, yes, I can answer some more questions while Brandon's trying to. Brandon, are you back?
Yes. Cool. I'm on hotel internet. Sorry. It's possible that we would switch to the Rust version should there be sufficient reason to do so. But if our for the short near-term future, we're going to use the Go one.
Are we using formal verification with OCaml? Brandon, I can let you field that one.
Yes.
Or maybe I can't because the connection's no good.
Now.
No. Okay, I will answer. Brandon. Okay. It's not good. It's not good. At least for me, it's not good. I'm gonna go ahead with formal verification. Yes. It's not just me, right? People in the chat, like it's not like yeah, okay. Quickly to answer formal verification, we're not using it right now. We are using the type system really significantly to take advantage of OCaml and get a fair bit of formal guarantees, but it's not as far as like formal verification. At some point, I think we would like to do this for like a large part of the code base. It's just like not there yet. I think like the industry will one day get there for cryptocurrency, everything be formally verified, but like in the future. Okay. Yes, it's definitely great that it worked till now, Brandon. Like, yeah, it's wonder what happened. Yes. Go. Coda is fairly technically easy to set up compared to other networks. I think this is because of two things. The biggest one is the ZK snarks, because like you don't have to download the whole chain history. You can really quickly sync to it. But also I think like our team has like started putting a lot of effort, or has put a lot of effort into making it really easy to get started with, like having things like, you can brew install it on Mac, and you can apt-get install it on Linux with no building from source. Things like switching to libp2p to make some things easier about connecting. It's been a priority for the team to make it really easy to connect, because we do have like these big goals for like let people to connect to it. So yes.
Yeah, and that hopefully you can hear me, but that that connects back to the strong UI and UX focus. Yes, just to mirror what Evan said, we spent a very large amount of effort to make it easy to connect to.
Yes, and if you can help us make it easier, please let us know and give us feedback. Yeah. Okay, we're coming up on 5 in the, or at least 5 in my time zone. Does anyone have any more questions?
All right. if there are no more questions, we will move on to the next panel. So anyone, final questions? Evan, I'm going to bring your video up real quick, if that's okay. Evan. All right. Well, thanks, everybody. We will start our next presentation at 5 p.m. and see you then. Thanks. Hey, great job, guys. Everything it's ended. So thank you, and we will keep in touch.
Okay.